Okay, so this evening we're going to look at three subtopics in algebra. We're not going to get into deep into the algebra, but we're going to look at three different things. We're going to talk a little about algebraic fractions. Then we're going to look a little bit at indices, and this is going to help you a lot with multiplying and dividing, algebraic terms. And then we'll see, I hope the time allows us. We're going to work at seeing if we can look at what we call transposing formula, right? Transposing. Or I'll use the singular. This is a plural, right? Formula, one, formulae, plural. And I think nowadays I don't say this anymore. You hear people say formulas and done, right? Good. So we'll take those three things. Let's see if we can cover them in our session today. I know sometimes these things, they can be very taxing after we're not speaking over just a whole day's work, but a whole week's work. Maybe the bosses insist you have to finish so much today. You were looking forward to your weekend and he wants his work done. Any one of you in that situation? All right, so let's start with this one. Algebraic fractions, right? Let's start with that. So we'll do some examples just to talk about how we can, and maybe we can start with addition and subtraction, right? So we start with addition and subtraction, right? Take those two together because sometimes the two operations are mixed together, right? So let's take two. Maybe you have to simplify someone. Simplify. Let's go with x over 4 plus x over, let's see, 3 plus x over, let's go with 6, right? So you have something like that. This here, you can see them sometimes written differently. You might see it like this: a quarter x plus 1/3 x plus 1/6 x. It's the same thing, right? It's the same thing. Well, you add these, you add them just like you would add fractions, right? You add them just like you would add fractions. So what do? You just find the LCM. LCM of 4, 3, and 6 is what? 12. 4 into 12 is what? 3. 3 times x, 3x, plus 3 into 12, 4 times x will be 4x. 6 into 12, 2. 2 times x is 2x. And you add all of that up, and you have what? 3x plus 4 is 7x and 2, 9x. 9x over 12, which you can reduce to 3x over 4. That's simple enough. Let's take another one. Let's say you have okay, let's go with 4 over 3x minus 5 over 3x. You can have this. Yeah, you can have this, right? You can have that situation. But just keep in mind that this is not the same as, it's not identical to 4 over 3x. No. And this is not identical to, no, it's not the same. No, no. Notice where the x is, right? Keep that in mind. Good. So what you're seeing here, oh my, I think I should change the denominator. Let me go with 4 here. Let me go with 4 here. Let me go with 4 there, right? Yeah. So again, what is your LCM? Your LCM is going to be 12x, right? So 3x into 12x will give us 4, 16. Put your minus sign. 4x into 12x will be 3. 3 times 5 is 15, and you end up with 1 over 12x. You think you get this one? So when you're looking for
Yes,
the
sir.
LCM, you're not looking for the LCM of 3 and 4 alone, because there's an x here and there's an x there, right? Let's take another one. Let's say you have to simplify I see this one in our notes. 9pq plus 5 over 18p. So what's going to be your LCM here? Your LCM is going to be 18pq, right? Can't be just p, because there's a q here, you see? So 9pq into 18pq is 2. 2 by 7 is 14 plus 18pq into 18p into 18pq is going to be q. Q times 5 is going to be 5q. And guess what? You simply can't simplify that beyond there. Clear?
Yes, sir.
Good. It's gonna get harder now. 8m minus 3n. I'm borrowing from the notes I sent you. Minus 2m minus 5n all over 3. Right? So you have to simplify that. So you find your LCM, which is 15. Oh, no problem there. 5 into 15 is 3. So you multiply that by the entire numerator. So it might be difficult for you to do it in your mind. Put back your minus sign. 3 into 15 is 5 times 2m minus 5n, right? And now you can remove your bracket. Oh my, scratch the screen. Yeah. So you get what? 24m minus 9n. So minus 5 by 2m gives you minus 5, minus 10m. Minus 5 by minus 5n will give you positive 25n all over 15. Right? So now we can simplify further. There's an m here, so an m there. You can actually, instead of rearranging, you could do it if you have that ability, right? 24m minus 10m will give us 14m minus 9n plus 25n will give us what? um, 16, 16n all over 15. Hmm? Is that right?
Yes, sir.
Good. And you can't do anything much with that, right? That's the best you can do. Yes, second. Well, let's do another one that might look a little difficult for you. You're asked to simplify. I know some of my letters aren't fully formed. Don't worry about that. Right? And what you do? You you remove the bracket using the distributive law, so you have what? You don't have to. You don't have to. You can remove the bracket now, or you could do it later. Right? You could do it like this, okay? 3x plus 12 over 7 minus 4x plus 4 over 5. And it resembles the previous one, right? And you add like before, you find your LCM being 2 to 5 and so on. Alternatively, you can leave the brackets there. And this is what you could do. Let me show you an alternative way. Leave the brackets and find your LCM. So you have what? 2 to 5. 7 to 2 to 5, 5. 5 by 3 is 15 minus 5 into 2 to 5, 7, 7 fours. X plus 1. And then remove the bracket, right? Then remove the bracket. So you can get what? You get 15x plus 15 fours is what? 60? Minus, okay, minus 28, 28x minus 28, right? All over 25. And then you simplify up here, right? What's that? Okay. 15x minus 28x will give you what? 8 and 5 is how much? 13 minus 13x. 60 minus 28 is how much? 8 from 10 is 2, 2 from 5 is 3, right? All over 35. I hope my arithmetic is correct. And this doesn't look nice. So what we'll do, write 32 minus 13x over 35. Right, that looks nicer. I'm not going to show you every conceivable type, right? There's very little bit of reading on your part, and sometimes you got to think. You don't have to see a problem or, like the one you did in class every time, right? The real world is not like that. You're going to meet things that you say, I never see this in my life. It happens to you. You hear people say things that you have never heard before in your life. You see people do things and ask you to do things that you've never seen in your life. Like this morning, I just want to mention this. I know it might be in the recording. I'm going to buy some meat from the butchers on the road. And the road usually in the morning is very, very, very congested. I mean, everybody knows that. So this car kind of give this guy on a motorbike a little brush, I don't know. I didn't see the incident there. I don't know who was wrong, but the car stopped now. The guy came out, and guess what the motorbike do now? He pick up a wood. God knows where he find it from. and he beat the man mercilessly. He broke this man. Imagine if he didn't, he wasn't hurt. His bike probably just get a little brush and he'll wobble a little. The man come out with a wood and the man come out the bike. I don't know where he find the wood if he had the wood on the bike. Nobody knows. Man broke this man car up, broke up all the windscreen, beating this man car. So when he finished, them bikes, the people, they had some guys who were on top of a truck. They could see the action because a crowd formed. Beat the man mercilessly. By the time the police meet, he don't do all that. Broke up the car, beat up the man, and he stand up just like that. God knows what mood he left his house with. Anyway, the police locked him up. So that's the reality of this world now. Huh? All right, so that's quite a bit there on addition and subtraction. Let's deal with multiplication now. Multiplication and division of algebraic fractions, right? Let's deal with that. And as I said before, these are much simpler to deal with, right? Just like how when it was multiplication, division of just an algebraic expression, algebraic fractions are even easier. And when we do a little bit of indices after this, you're going to see how it becomes even easier. So I'm not going to do too many of them. I'm just going to open up your appetite for it. And then when we do indices, you'll see how it becomes even easier, right? So let's start with a little example. Let's see if we can, okay, let's say we want to simplify, okay, a square over b square c cube. I want to multiply that by maybe b cube c square over, let's say, a. Well, the beautiful thing about multiplication, you can cancel any numerator with any denominator, right? So we see here, there are no similar bases, right? This is A, this is B, they're all different, right? A, B, C. But we can see that you can cancel across like this, right? So let's start with, okay, B square. All right. We haven't done indices, so let me not do it that way. Let me not do it that way. What this is equivalent to, we can write it out. A multiplied by A over B multiplied by B multiplied by C multiplied by C multiplied by C multiplied by B cube is B by B by B multiplied by, oh my. Let me move it along, right? Multiply, this C square now is C multiplied by C all over A. And now we can do some canceling, right? So maybe we can cancel this A here with one of these. We can cancel this B and this B, right? We can cancel this B and this B, right? And we can do this C and this C, all right? We can do this C and this C, right? And we're left with what now? We're left with A times a B. So we got AB in the numerator, all over what's left at the bottom here, only a C, right? See that? When we do indices in just a moment, you will see how we don't have to write out this long thing here. You'll see just now, right? Just let's do one with division and then we'll move straight away to indices. Right? So let's do one with division. So we want to simplify p cube x over qr divided by py over q squared r. Look at that. So this is equivalent to p cube x over qr multiplied by, remember fractions, q square r over py, right? It's like you flip over the divisor and multiply, right? Good. You get it so far? You understand how I change this to a multiplication sign and flip over, right? The divisor. You all agree with that?
Yes, sir.
Yes, sir.
Good. Our next move now is to take this and kind of expand it out now. So this is p by p by p by x over q by r multiplied by q by q by r over p by y, right? And we can cancel any numerator with any denominator now. So we can go with, all right, this q and that q up there. Then we can do this r and this r. So we can go with the p's now, p and this p. Nothing more. Do we? Yeah. So we got p by x is ppx. Okay, no, there's a q over here, right? All right, let me not write it that way. What am I saying? P by p, you got p squared x times q, right? So you get p squared x q over y. And if you want to put q before x, that's not a problem. So that's how you do multiplication division. It's very simple. The addition and subtraction is a little more troublesome. Have to find LCM. You got to be careful of a lot of signs and so, right? But the multiplication and the division, much easier. And it will become even easier when we look at the laws of indices. Right? So that's what we're going to look at next. We're going to look at the laws of indices. So I want you to give me a moment. Let me, okay. 1 second. Good. I'm going to chop some the laws of indices. And bring it over here. Oh, yeah. I think it's a little fuzzy, huh? Can you see it clearly? This means
Yes,
a
sir.
to the m
Yes,
power
sir.
times a to the n power. It's equivalent to a to the m plus n. It's like you add the indices. With division, you subtract the indices, right? And these here, they really come from these. A to the minus m simply means 1 over a to the m. A to the m power raised to the n power is equivalent to a to the mn power. A to the m over n power is like you're raising a to the m power and finding the nth root. And any non-zero number, right? Any non-zero, not zero, any number, right? Raised to the 0 power is 1. Clear? Let's do some examples to show you, especially how multiplication and division becomes easy now. Right? Let me see. Let me look at maybe. Let me find a hard one. All right, let me do this one. I want to keep the laws right here, so they're not too far, right here. So I work right in this area here, right? So let's say you have to simplify something like this. Simplify 3x to the fifth power times 2x to the fourth power y times 4xy squared. You know, horrible looking. Now we have no need of kind of expanding the whole thing out. So we don't have to write x to the fifth power as x by x by x by x by x by x 5 times. No, we got to do that, right? We have the rules now, right? We have the rules. So some people, you know, they can, okay, they might not want to watch the thing until the answer. Some people will do different things, you know. So they'll take the 3 by the 2, you know, they put all the like terms together and multiply, all right. Then all the x terms, all right. Some people do that. Then all the y terms, some people do that. You can multiply now. 3 by 2 is what? 6 by 4 is about 24, all right. Now, the laws of indices, the base now is the same. So we add the indices, right? We add the indices. Indices is the plural for the word index, which is another word for power, right? So when the base is the same, we can add the power. So we put x to the 9 power. Oh, sorry, 9. I was tempted to write q. No, there's another x here, sorry. So there's a power 1 there. So this will become 10. I didn't see that. I'm getting drowsy myself. X to the 10 power, okay. And then y now, there is a 1 here, even though we don't write it. Y to the third power, we add the 2 indices. Right? So this is the same as this, is the same as that. Some people would not even do this. They would watch the thing, just multiply the numbers in front here. 3 by 2 by 4, 24. X to the 5 and x to the 4 and x here, they just add up the powers. 5 and 4, 9 and 1, 10, you put x to the 10. Y to the 1 power and y to the 2 power here, you just add up the power, you put y to the 3, and that's it. Some people, with practice, because they've been doing this over and over and over, they actually would, like, you know, watch the thing and tell the answer. There are some people who are that good. Just give me 1 second. You follow this one? Easy to follow? Tell me, you know.
Yes, sir.
So we made
Yes,
use
sir.
of this force law a lot, right? I'll leave it here and I'll remove this. And put another one right alongside here, you know. Maybe one that deals with division. Huh? Let's do that. One that deals with division. Let's see if we can. 8x to the, all right, let's go with fifth power. Y divided by, let's go with 2x cubed y. Let's go to the second power. Right? So we can write that like this. 8x to the fifth power. All right, let me. Y over 2x cubed y squared. You can do that, right? And you can divide 2 1s, 2 4s, You can now subtract the indices, right? Subtract that from that, you get 2 there. Well, here, watch what happens now. When you subtract 2 from 1, what happens now? You get -1 here, right? You can do that. All right. Kind of queer. You get y to the -1. But there was an easier way to do this, right? So this you have 4x squared y to the -1 over x, right? No, this x, yeah, there's no x here. Yeah, there's no x here. The x cancel out, right? So you get 4x squared y to the -1. But like, this looks ugly. So that's equivalent to 4x times 1 over y. Remember this rule? This one here? Right? So now it becomes 4x over y. Right? If you really know your stuff, you could have taken away this one from this 2 and leave the y there, right? That will work too. That will work. But we are used to taking away the powers from the denominator from the numerator and not the other way around. But it can be done. It can be done. Right? See if you follow that one.
Yes, sir.
Good. So let's try another one. Of course, they have more examples in the notes I sent you, right? So let's try another one. Let's say you have to simplify. Okay, they have this one, 27 to the -1 term. You want to simplify that. Simplify that. Well, what you want to see this 27 as, it's what, 3 to the third power? Huh? Isn't that true? 27 is 3 to the third power. See if you agree. So you apply this rule now, this rule where you multiply the power in there by the power out there, right? And you get what? You get 3 to the 3 multiplied by -1 third, which is equals to 3 to the -1, which is equal to 1 third. Right? That's one way. That's one way. You could do another thing with it too. Let's see if I can do this. There are other ways of looking at it. I'm thinking if you do this, if you do 27, that would be a harder approach. Let me not do it that way. I want to confuse you more. Let's take another one. Let's take, we want to simplify. Eight over 27. Let's go with 1/3, right? So 8 can be written as 2 to the third power. We just said 27 can be written as 2 to the third power as well, right? Multiply by, okay, raise to the 1/3 power. This becomes 2 to the third power to the 1/3 over 3 to the third power to the 1/3, which becomes 2 over 3, right? Because when you multiply 3 by 1/3, it becomes 1, right? 1, and 3 by 1/3, another 1. So you end up with 2 over 3 as the answer. Think you get it? And some of them will put you to think. I don't want to do every possible um, type of problem there is. That doesn't help you, right? You need to be given a couple of problems where you have to think and use the laws, get it wrong, sometimes no problem, go at it again, you know, until you crack it. That's the beauty of mathematics, right? Good. Let's apply this to, oh man, yeah. Um, Solving an equation where the unknown is in the index or the power, right? For example, let's say you have to solve something like solve uh, 2 to the x minus 1 over 4 equal to 64. You have to find x. What do you do? Well, let's see if we can simplify this. So we can take this 4 over here and multiply that. So you get 2 to the x minus 1 equal to, all right, I wouldn't write it as 4. Let me show you what I'm saying. I'll write this 4 as 2 by 2. Okay, let's say 2 squared. Let's go with 2 squared. 2 squared. And then 64 is what? 2 by 6? Is that right? 3, 4, 5, 6, right? They're right. Tell me if you agree so far. So then the equation becomes 2 to the 8th power, right? And if the base is the same and they're equal, then x minus 1 equal to 8, which implies that, so this implies that the power is equal because the base is the same, right? And it further implies that if x minus 1 equal 8, then x equal 9, right? You take the minus 1 over the equal sign. There you have it, right? So you have solved an equation where the unknown is in the power, right? So you have equations like that. Let's do one more. Let's do one. Um, let's say we have to solve 5, 3 to the x minus 2 equal to 125. Look at that. Right? So you try to write this with a base of 5. So 5 to the 3x minus 2 equal 5 to the third power. So since the base is the same, that implies that 3x minus 2 is equals to 3, which further implies that, okay, well, you solve now. This is a simple equation, right? 3x then is going to be equal to 5. X then is going to be equal to 5 over 3. Right? And that's your answer.
So
Simply
I'm
enough.
not seeing anything.
Simply enough. All right, good. So what we can do, we can pause there a little. And then when we come back, we're going to try some that topic, changing the subject of the formula or transposing a formula, right? So let's take a little break there. We can come back at 6:30. Let's take a little break there. Pause. So we're going to look at transposing formulae, right? And this particular topic is a very useful topic. The reason why is that it's going to help you in a number of ways. You might have a formula. Let's say, okay, you have a formula. Area of some circle is pi r squared. You know, and yeah, maybe you're given the radius and you're asked to calculate the area. But what about if instead you're given the area and you're asked to calculate the radius? What you might end up having to do is you might end up having to find r, whatever it is. You have to rearrange this formula to find r. And then the formula, of course, when you find r, is going to involve a somehow over here and pi. And you will substitute what a is and pi is and get r. You see, so being able to transpose a formula to change the subject, it's a good skill in mathematics, right? It's a good skill. Also, your ability to transpose a formula can help you with the solution of almost any problem because you're going to be able to move around variables in a formula. For example, I can't remember if we did some quadratics earlier, right? We had the formula ax squared, sorry, the equation ax squared plus bx plus c equals 0. And I think I'm trying to remember if I gave you that x is equals to minus b plus or minus the root of b squared minus 4ac all over 2a. Just imagine, it is by means of a transposition that this formula came into being, right? So it can help you with that kind of thing. I mean, you got to be really good to know this, though, to move from here to here. Then even when it comes to solving equations, let's say you have, okay, 2x plus 1, all right, equal to, some number over here, making x the subject. That's what you basically do when you're solving for x, right? So it can help you in even the solution of equation, you see? So there are lots of uses of it, and therefore we're going to cover some basic formulas, that basic types, I would say, so that if you ever see formulas of that sort, you'd be able to, move them around and change the subject and so on. Some of them are very, very advanced, and I'm not sure whether you're at a level to do it yet, but this will be a good start, right? So let's do some examples. So, okay, all right. In physics, there's a nice formula, right? Um, change the subject of the formula V is equals to U plus AT to make U the subject, right? So you want to make U the subject, this here. Well, you have AT connected to U, so all you got to do is subtract AT from both sides. So you do that, you take, okay, let me write it, this is subtract AT, right? And that's not the word at, right? That's this AT here. From both, from both sides, right? So you get V minus AT is equals to U plus AT minus AT, right? So you're left with V minus AT equal U, right? And this will become 0. You can write it back this way if you want. Right? So you have effectively made U the subject, right? Now, when we talk about the subject, means that's what is on one side of the equal sign and everything else on the other side. Of course, you can do the shortcut, right? You could just watch this and take AT over and change the sign, right? You could just watch it and say, oh, V minus AT equal U. You could do that too. That's no problem. Do you follow this one?
Yes, sir.
Yes, sir.
Good. So let's take one that maybe that involve a minus sign, maybe. Let's go with, I'm thinking of one that involve, I can't think of one involve a minus sign. Let's see, I'll find one. 1 second. There are some mosquitoes in here. All right, a simple one. Make H the subject of the formula U equal H minus PV. Right? Very simple one. So you take this over there and the minus becomes a plus, right? So you get U plus PV equal H. If you want to write it back, you can write it back as H equal U plus PV. That's up to you. Simple enough?
Yes,
Let's
sir.
take a little harder one that involve a minus sign. So let's say you have the formula 2 pi f. All these are formulas from physics, eh? W subscript 1 minus W subscript 2. And you want to make W2 the subject of the formula. So some people might want to say, all right, good, let's take away W1 from both sides. So you have 2 pi f minus W1 equal to W1 minus W2 minus W1. So these two are going to cancel out each other. You have 2 pi f equal, minus W1 equal to minus W1. Sorry, W2. But you don't want minus W2, you want positive W2, right? So you'd have to multiply both sides by minus 1. So you get 2 pi f minus W1 multiply by minus 1, which is equal to minus W2, sorry, yeah, multiply by -1, right? So you multiply both sides by -1. You end up with minus 2 pi f plus W1 is equals to positive W2. Now this doesn't look too nice. So you can put the positive in front and you get W1 minus 2 pi f equal to W2, right? Or if you want to write that back as W2 equal W1 minus 2 pi f, right? That's one way of doing it. Of course, there's a shortcut that you can do this as well. And let me share that with you. Instead of doing it this way, and a lot of people, a lot of students, who are very good at the maths and they do it over and over, you could do it this way. You could take this -2 over here and become positive 2, right? This minus W2, and bring this over here, and this becomes negative when it comes over here. So you end up with W2 equal to W1 minus 2 pi f. And voila, you get the answer in just one step. Right? So if you're very good, you will tend to develop that ability, Will we move on?
Yes, sir.
All right. Let's go with a little harder one. Not a hard one, but make R the subject, right? So you have V equal RW. Well, you could simply divide both sides by W, sorry. Yeah. You want to make R the subject, so you divide both sides by W. Right? And this W and this W cancel out. And you're left with, right? You want to write it back as R equal, no problem. Some people do the shortcut where they just take down the R, right? They just take down the R there, and you end up with V over R equal W. People could do that, right? Follow so far? And you can have a
Yes, sir.
combination of products as well as summation and so, right? Again, I can't show you all the possibilities, like the one we had earlier. Let's say you are asked to make T the subject, right? And you have V equal U plus AT. Want to make T the subject. Well, what you could do, you can start with taking this U over first, right? And subtract. So you end up with V minus U equal to AT, right? And here you have a product now. So you got to divide throughout by A. So you do V minus U over A equal T. See? So you have T equal V minus U over A. You can have those combinations, Tell me if you follow this one. Is it easy?
Yes, sir. Easy.
Good.
Yeah.
Let's go with, all right, those that involve division now. Like you have, okay, current, okay, let me not use those terms. Current is equal to voltage over resistance. Another formula um, from physics. Let's say they ask you to make V, the subject. Right? So what you can do? Multiply both sides by R. I multiplied by R equal to V over R multiplied by R. Right? So this R and that R is going to cancel out. You end up with IR equal to V. Right? Some people do it differently. They take this and they write I over 1 equal to V over R. And they do this cross multiplication thing, right? You get IR equal V. Now, some people do that too. What about if they say instead of making V, let's say they say make R the subject. R the subject. Well, a clever thing to do is what we said earlier. You can put I over 1 equal V over R. You cross multiply and you get IR equal V. But you're not done yet. You gotta make R the subject. Then divide both sides by I, right? You get R equal V over I. See, so it's not always a one-step thing and you get the answer. And sometimes some of them are a little harder. They might involve square root signs. They might involve brackets. You know, let's do a few just to cover some ground. You know, so you will see the kind of.
I'm doing the transposing. Like I used to make R the subject. Let's go back a little bit to the slide. When you say make R the subject, can you do, let's say, you take the V from the top and take it over the equal sign. It's dividing, so when it goes, it will be multiplying. And then you take over, no, I think it's wrong. You take over the R. When it's more dividing, it's going to be multiplying. And then you're going to take over the I over back. And it's going to become the same V over I. Can it be done that way?
You can, but you talk about 5 steps there at least, and I'm doing it in one, in 2. Efficiency is another thing you have to consider, right? Right? Efficiency, you don't want to waste time with the thing and do 5, 6 steps when you can do it in 2. You understand?
Okay.
So don't forget that when you're doing a problem, you want to look at how fast you can get the answer to. Right? Okay, let's take a harder one. So there's a famous formula in the sciences. T is equals to 2 pi root L over G. Look at this one. And let's say you want to make G the subject. So G is hidden all the way in here. Right? So one of the things you want to do first is maybe square both sides. Right? Square both sides. What happens when you square both sides? You get T squared over here. You square 2, you will get 4. You square pi, you will get pi squared. And when you square everything under the square root sign, you get L over G, right? So this can be written back. This can be written back like this. T squared is equals to 4 pi square L over G, right? What I would do now is put this over 1, cross multiply. So you end up with T squared G equal to 4 pi square L. And then you know the next step. You divide both sides now by t squared. So you end up with g equal 4 pi square L over t squared. Right? So that's how you handle a square root sign. You try to square things to get rid of it. Conversely, let's say you all still studying this one. You want me to leave it there a moment?
Yes, sir.
Let's take one that has a square inside already. Like the one I started off with, let's say I say, okay, given A equal pi r squared. You want to make R the subject, right? So you have a square on the R. So what do? Well, you can first get rid of the pi from there. So you get A over pi equal to R squared. You divide because here pi is multiplying. So you take it over, you divide. And then you square root both sides to get rid of the square sign. So you end up with A over pi square root of the whole thing equal to R. Right? So your answer is that one hard. All right, look at this one. This one, what you're making a subject occurs more than one place in the formula. Look at this one. You're given, all right, given V equal 3R, that's 3R over R minus R, right? So you have an R there, you have an R there. Say make R the subject. What do we do now? We take this on top of 1 and get 3R, R minus R. Cross multiply and see what happens. Make this to the side a little. So we got V bracket R minus R equal to 3R. Remove the bracket now. So you get VR minus V common R equal 3R. We got R here, we got R here. Could we get them together? Yes, we can. Bring this over here and bring this over here. So you end up with VR minus 3R equal to positive V small r. And now we can use the distributive law here and bring the R outside. We have V minus 3 equal to V common R. And you know the obvious next step. Take down this R and divide here. You end up, take down the V minus 3 and divide. So you get R equal VR over V minus 3. How that one look? Hard, right? So that's a little, introduction, I would say, right, to formula. Right? Some of them can get very, very complicated. Some of them can get very, very complicated. Right? But I'll send an exercise to you so that you can get some more practice from the very simple ones right up to the very difficult one, right? Good. So what we're gonna do next week, right? Today is Friday. I'm a little taxed with time, but I'm trying to see if I can send you an assignment to do. And the assignment would involve, let me see how many of you. It's not plenty of you. Maybe I can do it in the morning or before the weekend is out. So Monday, let me take a look. I want to stop the recording. Let me take a look.